Okay, so after that column, we just talked about the degrees of freedom column. This sum of squares column is going to be the next column that we're going to go through and work out. This first number here, this 16.96, that comes from the sum of squares column, and it's in the groups row. So this thing here is the sum of squares groups. Okay. This is a measure of the variability between groups. So I'm often going to denote this SSG for sum of squares groups. I'm going to give you a big ugly formula to be able to calculate it, and then we'll talk about where the formula comes from. So it's the sum of, so we'll use the big Greek letter sigma, starting at the first group all the way till the last group, the kth group. We're going to have Ni, that's the sample size in the ith group, times Xi bar, that's the sample mean of the ith group, minus X bar, that's the overall mean, and then squared. Whew. Okay, so I'm just going to pull in some of our statistics from before here. So here, if I wanted to just sort of label them, there was these three groups. So let's say the bottom group is the I is equal to 1 group, I is equal to 2 is going to be mid-depth, and I is equal to 3 is going to be the surface. Okay, so that would make this 6.04, that's X1 bar, X2 bar is the 5.05, and X3 bar is the 420. And then, not that we particularly need them, this is S1, S2, and S3, my different standard deviations, and this will be N1, N2, and N3. And then I've got the overall mean, so that's my X bar, that's for all of the different numbers. And then I don't have it written in here, but maybe I should. Overall, there's 30 total if I add together for all the groups, and that is my overall N. Okay, so if I wanted to kind of start working this out for this data here, I would start with the first group, and I'd have Ni, so that's a number in the first group, so 10 times, we've got 6.04, that's the mean for that group, minus the overall mean, 5.097, and then square it, plus, and then we'd plug in the numbers for the next group. So we've got 10 times 5.05 minus the 5.097 squared, plus, and then for the last group, there's 10 in that group as well. Its sample mean is 4.20, and then the overall mean, and then squared, okay? And when you plug in all those numbers, that gives you the 16.96, okay? You can see here that, you know, the farther apart these means are, the X1, the X2 bar, and the X3 bar, the farther those are from each other, the farther they're going to be from the overall mean, and this number here, the sum of squares group, is going to get bigger and bigger and bigger the farther apart the means are. Whereas if all of these means were very close to 5.07, we'd end up with smaller numbers here, and this sum of squares groups would be smaller. Okay. This number here, okay, it's in the sum of squares column, and it's in the error row. So we're going to call this the sum of squares error. Okay, so surprise, surprise, I'm going to denote this SSE. Okay, and again, let's go through the formula really quick. So the sum of squares error is the sum from I is equal to 1 to K of Ni minus 1 times Si squared. Whew. Oops, did that pause on the screen? Let me see if I can just fix that. Perfect, now you can see what I was writing there. So in this case, right, we would go through, and for each group, we're gonna plug in. So we'd have the first group, so 10 minus 1 times the standard deviation squared, so 1.58 squared, plus for the next group, 10 minus 1 times the 1.10 squared, plus 10 minus 1 times the 0.66 squared. So that's where the sum of squares error is coming from. It's not written in here explicitly, but there also is this sum of squares total. So it's just going to be the sum of the two numbers up there. So that is going to be 54.29, okay? And you can get that in a couple of different ways. So one thing you can do is you can always add these two numbers together. Your sum of squares groups plus your sum of squared errors always gives you your sum of squared total. So maybe I should write that in. Okay, so this thing here, that's our sum of squares total. That's always the sum of squares groups plus the sum of squared error. So that's an easy way to do it. The other alternative way of doing it or calculating it is by doing the overall. So we've got the sum from I is equal to 1 to n. So for all 30 observations, you're going to take that particular observation minus the overall mean squared. So this is just sort of a measure of the overall variation here. Okay. So like in this case, oh, I don't have the raw data all printed out, so I can't necessarily show you. But you take, you know, the first sample that was the bottom depth and then subtract off the mean of the bottom depth group and square it, plus the next observation from the bottom depth group, etc. Okay, again, I'm never going to have you work those out by hand, but I think it's useful to sort of see where these are coming from. This is a measure of the variation between groups. This is a measure of the variation within groups, and this is a measure of the overall variation.